Hello, everyone. In this lesson, I'm going to expose yourself to the kind of algebra you are going to do. These are actually derived from the actual questions in calculus text. Okay, these are also typical assigned homework if you take calculus 1. So reducing these kind of different kind of expressions here is something you are going to do. And these are not just examples, they are very typical exercises you are going to work with. So let's look at, depending on the amount of time, I try to keep time under control, not to exceeding too much over an hour. So let's see how we're going to reduce these. The first one, we want to find the domain, right? But our denominator is x squared plus 1 then squared. So the domain, x squared is always a positive or 0, right? So therefore, the domain is all real numbers. From negative infinity to positive infinity. In calculus, you're going to have to be very conscientious about domains of each function you're dealing with. Okay, so it's a constant requirement for us to be aware of what the domain of the function. And this is one of those typical examples, right? Then we're going to reduce, and we want the final answer to be in factored form. Okay, so I'm going to show you what we mean by it. The denominator is already written down, right? Nothing to be done. And then we're going to do, then we're going to work on the numerator, x squared plus 1. And x times 2x, that's minus 2x squared, 2x squared. And then what do we got here is going to be, x squared minus 2x squared, right? And that's going to be 1 minus x squared. To be in factored form, we will be writing it as in factor form. Then you say, why in factor form? Well, we're gonna, once you're in calculus class, you will find that there's a category of questions that we want to have a factor form. And there's another category of questions that you want to be in extended form. So we're done extending in another video. And this video, we're gonna do the factor form. Okay, so first one is done. Second one, the domain this time is not all real numbers because we need to guarantee the denominator is not 0. So x cannot be equals to 1, right? So all the operations we do are in the domain of the function. That's usually the rule of thumb. Okay, you don't operate if your variables is outside the domain. Once again, you can see the next one. Just work along my side, right? So we're going to distribute the 2x to x minus 1. So we're going to get 2x squared, right, minus 2x, right? And then we simplify. So this will really bring your algebraic skills to speed. And then in factored form. Then you're going to write it in factor form, and you're going to factor out the x, right? So it's going to be x minus 2 times x. So we have all these factors, and that's factored form. That's the desired answer. So you can do, so in a real calculus situation, when you're there, the next step, you can carry on with the next step. Okay. The next one The next one, we got, once again, the domain is all real numbers because we got this, the denominator will have this x squared plus 4. That's always positive. So we have no issue with the domain. And then we just need to simplify. We just need to simplify. To simplify expressions like this, you don't have to be so stuck up with, whatever way. You can, be flexible. You can be flexible. For example, in this case, I got that piece and I got that piece. I'm actually going to factor out the 2x. Okay, so I'm on this step, I'm going to factor out the 2x. So 2x is being factored out. And inside the bracket, I can remove this parentheses. When I remove the second bracket, I will get a minus x squared plus 4. Plus 4, right? And of course you can do the distribution if you want to do that way. That's fine too. And x squared minus x squared, that makes 0. So inside the bracket, we just have 8. So in the end, you get 16x. It's not that hard anyway, right? However, if some of you say, oh, I don't want to do it this way, I'm going to do it this other way, no problem. If you do it that way, you should get the same answer. You should get the same answer. So denominator is kept. Numerator, you take the 2x, multiply x squared, you're going to get 2x raised to the power 3. 2x times 8, you're going to get 8x. Subtracting, right? You're going to take the negative 2x times x squared. You get a minus 2x raised to the power 3. Whoops, sorry, this is negative. And then, what am I doing? 2x, sorry, I need to put this here. 2x here. Sorry, I put it in the wrong place, okay? And negative 2x times 8 times negative 4, you're going to plus an 8x. So once again, you're going to get the same answer. Okay, so 2x, negative 2x raised to the power 3, 2x raised to the power 3, that makes 0. 8x plus 8x, you're going to get 16x. Same answer, same answer. So any way you do it, okay? I'm not specific about you're going to, I don't require you have to do algebra in the way I do it. And you can do it your own way, but the answer usually is unique. Okay. Keep going. Keep going. And this time the domain would be that 3 minus 4x cannot be 0. So x cannot be, okay, 3 over 4. Okay, so you just basically said 3 minus 2x equals 0. Right? You set it equal to 0 or not equals to 0. It's up to you, right? You just have to figure out that logic. And then, of course, x is not equals to 3 over 4. Divide both sides by adding 4x, divide both sides by 4. Okay? So on this question, just keep going. 2 times 3, that's give you 6. And 2 times 4x is a minus 8x, right? So 6 minus 8x. And the latter one, negative 4 and negative sign, that already made a positive, right? So I can put and then 1 times 4, that's going to be a 4. And that's going to be 4 plus 8x. 4 plus 8x. Okay. And a positive 8x and negative 8x would make 0, and we get 10 on the numerator in the end. So that's the factored form. Okay, so we get a couple more. Actually, we get quite a few more. I'm just watching the time, so I don't exceed 1 hour. Okay. So this time we're gonna have to FOIL these two. So when I FOIL these two, to be extra cautious, okay, I would like to put a bracket. So I'm going to FOIL only this part. The negative sign, I'm going to leave it out. Okay, so I'm going to do x times 2x. That's going to make it 2x squared. X times negative 1, so that's minus x minus 2x plus 1. I'm combining this as minus 3x. Okay, then that's my habit. Okay, so I don't mess up. So this negative sign is distributed to everything inside. So when I remove the bracket, so this will be changing sign. So this will be minus. Okay, so these are just extra caution I took. I'm combining like terms. Negative 2x squared, x squared, that these two are combined. So we get a negative x squared. Minus x plus 3x, that make it plus 2x. Positive 1, negative 1, that makes 0. And we prefer the answer to be in the factor form. So last but not least, we're going to factor out the x. Right, so 1x is out. Okay, so that's it. That's the answer. If you like to write it in an alternative form, that's just, you can write this as 2 minus x, which is the same as, so these two forms are exactly the same. Okay, there's no preference whatsoever for my part. Okay, so that was number 5, right? You can do it in different ways, but it's pretty much, just to practice your algebra. These are the opportunity to practice your algebra, and these are the actual exercises you will be doing in calculus. So you can do it now. You really have some advantages. Your algebra will be much reviewed and much improved. Okay. Number 6. Did we say oh yes, we haven't mentioned the domain for number 5, right? So what's the domain? To set up the domain for number 5, okay, here we're gonna have to talk about the domain for number 5. To determine the domain for number 5, first I'm gonna set it equal to 0. Right, so we're gonna find out what real numbers that will make this quadratic equals to 0. Those numbers should not be in the domain because that's in the denominator. But to solve this equation, we're going to use the quadratic formula, right? So we're going to look at b squared minus 4ac minus 4ac. So in our case, b is negative 1. So negative 1 squared minus 4 times a is 1, c is 1. So this is actually 1 minus 4. Okay, so negative. What does this tell me? This tells me that there's no real number solution. So this quadratic, there's no real number solutions. What it means is that this quadratic form is entirely above x-axis. You can picture it. You can picture it. Okay, the graph is entirely above x-axis. This may look not, but if I make some adjustment, right, with the right scale, you can see, because the theory already tell us that this curve is above x-axis. What does that mean? That means the denominator will never be 0 because the entire curve is above x-axis. Therefore, the domain is all real numbers. Because this says there's no real number to cause this denominator equals to 0. And therefore, this domain is also from negative infinity to positive infinity. All real numbers, okay? So this here, we reviewed a little bit of, a quadratic formula. If necessary, there will be, in the future, there are other lectures to review this part. Okay, so for now, I just put out this much. If you have questions, please let me know so I can review more for you. All right, so all of these tools are your algebra tools, okay? The next one, domain, right? Obviously, 2x plus 1 cannot be 0. So domain is x cannot be negative 1/2. Negative 1/2 is a number that cannot be. So that's the domain. Okay, so we got the domain. So all the operations will be done in the domain. So 2x times 2x, we're going to get 4x squared, right? And plus 2x, right? So we just distribute 2x times 2x, 2x times 1. So that's get 4x squared plus 2x. Minus 2 times x squared, that's minus 2x squared. And minus 2 times minus 2, that's positive 4. So that's going to be plus 4. Okay. And next, negative 2x squared, positive 4x squared. So these two combined, we're going to get 2x squared positive plus 2x plus 4. All right. Can we factor this? Can we factor this? We can factor out the 2, right? So this is a 2, this is a 2, this is a 1, this is 2. Can we factor this further? Can we factor this further? That's another question. Can we factor this further? To confirm whether we can factor this further, because in calculus, you will also need these these knowledge. Because you will most likely, after you have done this part, you have more steps to go. So x squared plus x plus 2, once again, this is a quadratic function. This is a quadratic function. For this quadratic function, right? For this quadratic, can we factor it? Can we factor it? Because if we can, the factored form should be equals to x minus x sub 1. I'll explain to you what they are. X sub x minus x sub x2. X1, x sub 1, x sub 2 are solutions to the equation 1 is equals to 1 equals to 0. So you can apply quadratic formula, but before you apply quadratic formula, I will do the b squared minus 4ac. Okay, b squared minus 4ac, and then the b is 1. So it's 1 squared minus 4 times A is 1 times C is 4. I'm sorry, C is 2, sorry. And this is negative one more time. And what does that mean is that there's no real number solutions. No real number solutions. No real number solution meaning that you're gonna get a complex factors. But complex factors usually is not not gonna be any use for calculus 1. Okay, so this will end up with x1 is a complex number, x2 is a complex number. So we call this kind of situation, okay, irreducible quadratic. So this is irreducible quadratic. And what it means is actually this piece is always positive. Okay, so you can see this by plotting this quadratic. Okay, this is always positive. It will never be 0. So in the situation that you encounter in calculus class, you're not gonna get you're not gonna get any real number. So this is always positive. So if you set it equal to 0, so pretty much you know that this is a positive, the denominator is positive, the whole thing is going to be positive. Okay, so this is the whole thing is always positive. That's what it says for us. So this whole thing is positive for any real number. Okay, so you can see how we use our algebraic knowledge to work the algebraic to calculus questions. Okay. Number 7. Okay, so this is another reducing questions. To determine the domain, we need to set x squared minus 9 equals to, say, equals to 0, right? So you can solve this equation. You're going to get x squared equals to 9. And then you're going to get, you're going to take square root on both sides just to determine the domain. Okay. And the next step is you get absolute value of x equals to 3. So x would be equals to plus or minus 3. So the domain would be x cannot be equals to plus 3 or nor minus 3. It cannot be positive 3. It cannot be negative 3. Okay, so that's the domain. So everything will be operated in the domain. So we're going to continue to reduce. Okay, to reduce it. All right. We can do it once again, factored out the 2x, right? And remove the parentheses. So this is a minus. And x squared minus x squared, these are gone. So we got it. We're getting there. So we get a -9 plus -9, or -9 minus 9, that's -18. -18 times 2x, that's -36. Okay, -36x. Done, finished. Okay, all right. Let's look at the next one. This one looks pretty straightforward, right? Domain. domain is all real numbers because we got 1 plus x squared, right? So domain, all real numbers from negative infinity to positive infinity. That's what x can be. We will need to find common denominator. And so the common denominator obviously is going to be the only denominator, the only significant denominator, right? And the second part. And then we just operate on it. So 1 plus x squared minus 2. So this piece will be gone. And then 1 minus 2. So this is going to be x squared minus 1. And we want to be in factored form. And we factor x squared minus 1, x squared minus 1. That's going to be x minus 1 times x plus 1. Finished. Done. Okay. I'm sure as you follow along and you are getting better and better at this. And these are the real algebra in calculus. Make sure you practice them often. Okay. You can factor out an x, or you may want to just directly distribute. So 2x times x raised to the power 3, that's going to be 2x raised to the power of 4, right? 2x times x raised to the power 3, and then minus 2x. The latter part, 2x minus 3x squared times x squared, that's going to be 3x raised to the power 4 minus, right? And negative 3x squared times 1, and that's going to be minus 3x squared. These are the steps, okay? I always want to take more time to double check and double check. We haven't talked about the domain yet. Okay, we'll be right there. Okay, we'll be right there. Let's keep going. And there's a combination. So we're gonna have 1x raised to the power 4, right? So these two combined. And 3x squared minus 3x squared minus 2x. So everything on the top are negative. So in this case, you know what I would do? I will take out the negative sign. I'm going to take out the negative sign and put it in the front. Sorry. Okay, so the negative sign all factored out. They're moved to the outside, and arrange things in the from the exponents is in decreasing order. All right, so then I can factor out an x, right? So I can factor out an x. So 1x is out. So this is out. This will be 3, and we got an x. And we factor further. I think to factor this one further would require some extra work, okay? Would require some extra work, require some other factoring techniques. So for the moment, okay, there are a lot of other factoring techniques we're going to need, you can use, but for the moment, for the sake of, simplicity, I'm going to just pause, just stop here, and we go on to find the domain. Okay, so we're going to decide the domain. We just leave it there. We'll just leave it there, okay? You set it equals to 0, then we get x to the power 3 equals to 1, and then we're going to take a cubic root, right? So x is going to be equals to 1. So the domain would be x cannot be equals to 1. About factoring this one, okay? If we have time, we'll come back to it. If we don't have time to it, you just have to deal with it when you see such calculus questions, and most likely you will, okay? The remaining questions, okay, we just finished up 31 minutes. So for the remainder questions, there involve radicals. And this is another category of questions that I like to expose yourself. And all of these questions are from calculus textbook. So how do we deal with these kind of questions? Okay, we also want the result to be in factored form, right? So once again, common denominator. The denominator is here. So on this piece, right? So I'm going to write down everything here. And this x, I'm going to write it on the top. I'm going to put an x over here. This piece doesn't have a common denominator, doesn't have the same denominator. So we're going to make it to be as such. Oops, sorry. I just need this piece, okay? Common denominator. So that's the common denominator. As you can see, if we make it the common denominator, right, we're going to discuss the domain soon. Now we have the same denominator, right? But this piece, multiply that piece, right? We get that. So this piece is being squared. All right. So for that, I wish to remind you, I have these facts, right? If you have root x squared, it's going to be equals to absolute value of x. But if we have root x, the square is outside, that equals to x. Okay, take it for now. Okay, so that's what we have. So we have the latter form. Okay, so this piece, okay, after it's been squared, we will end up to be x minus x squared. Okay, continue. We have the same denominator, and we just operate on the numerator. So this piece will be adding this other piece. Okay. And then what? Combining like terms, right? So 2x to minus 2x squared, right? And over here is x minus 2x squared. So x minus 2x squared. Do we have any cancellation? It looks like not, right? So we got minus 4x squared, and this is just 3x. Factor form. So we can factor out the x. We can factor out an x here, and x is being factored out there. Factored form, okay? So this to reduce. In terms of domain, to set up, to find the domain, we need to set this piece to be greater than 0. It cannot be equal to 0 because it's in a denominator. So we're going to solve this inequality. We're going to solve this inequality. Okay, I'm going to keep everything. Oh, how do we solve this inequality in order to determine the domain? Okay, I got some quickies for you to find out, right? So E1 minus X greater than 0. You can see this involves solving a quadratic, right? If we set this equal to 0, we get two crossings, but we know this is a quadratic. Quadratic is very often, showing up in our calculus courses. Okay, so here I'm going to show you the picture one more time. So you know what I'm talking about. Okay. There we go. Okay. So these two, you can see if you set this equals to 0, right? If you set this equal to 0, you get 2 points of intersection. One is 0, the other one is 1, 0. So these are 2 points of intersection. And this is the curve. You can see the curve. We want the curve to be above, right? To be positive, right? So let me give you a little better picture here. So maybe it's -3 to +4. And -3. There we go. So to make it positive, right? To guarantee this is meaningful, X has to be the domain. The domain is actually very small, just this piece. Okay, to guarantee that. So our domain is X between 0 and 1, just to guarantee that piece is greater than 0. Okay. So I skipped some details because we will be talking about these things in the future, okay, about quadratic. So next, another quadratic. This quadratic, first of all, you can see the domain. Well, 2 plus X cannot be 0. And root X here is in the denominator, right? So you can see X cannot be 0. Oops. X cannot be 0, right? And X cannot be -2, right? So in this domain, we simplify, we reduce it. How do we reduce it, right? So this is the common denominator. So what we can do is that we're gonna multiply that common denominator over the common denominator. All right? And then what? We take the 2 times radical X, right? We multiply that piece. And we multiply that piece. We take this piece to multiply that. Okay. It's some very basic algebra, really, guys. Okay, that's what you're gonna need to do. Simplify, this makes 1. And this is root x times root x, that's x. And we're almost there. We are almost there. Okay. So no stress. The more you practice, the less stress you're going to be dealing with. Okay. So this is going to be 2 minus x. Okay. Finished. Can you take away the 2 above and below? The answer is no. 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 Okay. Let's make this one. I'm debating because it's over 40 minutes now. We have several other questions that probably needs a much more than 20 minutes. Okay, so I'm gonna, after number 13, we're gonna stop. We're gonna stop. Now, domain. Domain for this one is all real numbers. All real numbers. So negative infinity to positive infinity. Okay. So we're going to find common denominator. And one is going to be written as root of x squared plus 1. And then that one. And then what? Then what? Now we got the common denominator. It's going to be x minus that root x. Right? So this part is gone. In some situation on this question, you're done. However, in a calculus text, in a calculus setting, sometimes when we get to this point, we may have to go further. I mean, I say we may, okay? So how do we go further? Typically, we want to do some conjugate thing, right? So the conjugate of the numerator, which is going to be x plus, we're going to multiply the conjugate of the numerator to write it this way. And then, so this will be a typical calculus, question, okay? And then we get this piece times that, right? So that's a typical of a minus b times a plus b. So that equals to a squared minus b squared. Okay, so that's what we're using. So the numerator, right? So this is a plus b. The root is this is a b. This is a. So this is a minus b. So a minus b times a plus b. So we will end up with, right? So we multiply these two. We get x squared. And that piece is going to be squared. Okay, and the next step, okay, I'm doing this hypothetically, because in a calculus situation, you will in that setting you will know what to do. Okay, and this is one of the typical situations you are going to work with. Okay, so this piece is going to be, you're going to end up with x squared plus 1. Okay, you're going to end up with x squared plus 1. Okay, and then you can see x squared minus 1. That's going to be what's left on the top. Okay, so on the top is going to be -1. Then you say, what about the bottom? In the bottom, you can leave it as is. You could leave it as is, or you can write it this way. You can write it this way. You can take this piece and make it, join it under the same denominator and remove that part altogether. So this could be a scenario that is needed in calculus. It could be this scenario, okay? So all of these two cases are all possible. And I would have to say, you should know how to go from here to there, because in some situation, this is needed, this to get to this point. All right, we have several other questions, and I think I'm going to put on a different recording. Okay. Now is 46 minutes, and I think that's a good length. That's a good length. We don't want to make it too long. So let's just recap to see what have we done. Right. Primarily, you're going to exploit your previous algebraic techniques, right? Including common denominator, combining like terms, determining domains, and that's all you're going to use. And also knowledge about quadratic functions. Okay, knowledge about quadratic functions. I assume that some of you guys probably need some refreshing. So there will be topics on quadratic as needed. Okay, I will definitively make those lessons to make it available to you. But all of these, please practice and work it out. Work along my side or work by yourself. And thank you for watching.